So in this video, we're going to now look at using Laplace Transform to solve initial value problems. These are second order initial value problems. The reason why I have the table open is because we're going to need to use our knowledge of inverse Laplace transformations that we used in the last video to solve these as well. The basic idea is we're going to solve for y of s. Now you might ask, what is y of s? Well, I'll tell you. The Laplace transformation of y is y of s. The Laplace transformation, I cannot write a bracket for the life of me, of y prime, oh my god, is y of s, y of s minus y of 0. The Laplace of y double prime is s squared, y of s minus s y naught minus y prime naught. The Laplace of y triple prime is s cubed, y of s minus s squared, y naught minus s, y prime of 0 minus y double prime of 0, and so on and so forth. You get the pattern now, right? If I were to go to the Laplace of y fourth prime, s to the fourth, ys minus s cubed, y naught minus s squared, y prime of 0 minus s, y double prime of 0 minus y triple prime of 0. And you just keep going on and on and on. I've had cases where I had something like this, by the way. Kid you not, my professor was evil. But anyways, let's dive right in. Well, yes, we're solving for y of s, by the way. And you can see how these initial value problems work. We have a y naught, we have a y prime naught. Those happen to be initial values, don't they? But anyways, y double prime. What was y double prime? Well, we start with the second degree and always a y sub s. And then always follows a y of 0. It's always subtraction, by the way, always. And then we start with the primes. Okay. Plus 3 y prime. So 3 times s y of s minus 3 y of 0. And we have plus 2y. Y is just y of s. And that is equal to 0. Now we have these two beautiful initial conditions here that we can go right ahead and plug them in. We got multiple y of 0s. We have a y prime of 0. S squared plus 2 y plus 3 s y of s. I prefer to write it this way. Minus s minus 0 minus 3 plus, that's it. So let's solve for y of s. Y of s is equal to s plus 3 divided by s squared plus 3s plus 2. Now doesn't this look familiar now? So now all that's left to do Take the inverse Laplace. this is just like the same thing, except for instead of using f and s and f and t, we're using, sorry, this should be a capital Y of s and a lowercase y of t. That's the only difference. So we found our y of s. So there's a certain cycle, if you notice, to these problems. Here, I have a nice picture here. These problems all have a nice little cycle. We start with our ODE, right? We go to our equation. We get our solution, which is y sub s. We then take the inverse Laplace to get our y of t. And we then go back to our I.V.P, right? Which I should call it, I guess, an I.V.P. Right? This is when we so yeah, we took so this is our I.V.P, right? We take the Laplace, and then we get this equation here, which is this. This is our equation. This is after we take the Laplace. We're taking the Laplace of y, y prime, y double prime. We get our equation, and then we get our solution, and then we take the inverse Laplace. So it's a big cycle. It's a one big cycle, right? So now we take the inverse Laplace, of course. What could this be? Well, based on the denominator, does it factor nicely or not? As opposed to, yes, yes it does. S plus 3 over why didn't I just, let me just put it up here, save some space. S plus 3 over S plus 2 times S plus 1. That's adds to 3, multiply, yep, we're good. That would leave us with S plus 3 is equal to A over S plus 2 plus B over S plus 1. S plus 3 is equal to A S plus A plus BS plus 2B. S is equal to A plus B. 3 is equal to A plus 2B. A is equal to 5 minus B. So 3 is equal to 5 plus B. So B is equal to negative 2. If B is negative 2, A is 7. Let me check that. B is 2. Oh, positive 2. Is it though? Yeah, I did it wrong. Wait. S plus 3 is equal to A times S plus 1. Yes, plus B times S plus 2. Yeah. S is equal to A plus B. 3 is equal to A plus 2B. A is equal to 5 minus B. 5 minus b. Yes. 3 minus 5 is negative 2. B is equal to what am I doing wrong? Oh, that's a 1 is equal to a plus. That's an s, not a 5. You take the coefficient. What am I doing? So that's 1 minus b. That's b is equal to 2. There we go. If b is equal to 2, a is equal to negative 1. I need another page. That's negative 1 over s plus 2 plus 2 over s plus 1. Let's look at our Laplace table. We have s pluses. So sine and cosine most likely. I would say, wait. They're not squared. It would be e to the at. In this case, we have minus e. Oh my, what is this? How do I undo that? Minus e a would be negative 2t plus 2e to the negative t. Right? I used this over here. This right here. Not too bad. And this would be our y of t, which I should write this out. The inverse Laplace of y of s is equal to y of t, which is equal to this. See that? Not too shabby. Not too bad. All right, this one, number 11. Y double prime s squared y of s minus s y of 0 minus y prime of 0 minus 2s y of s minus 2y of 0 plus 4y of s is equal to 0. We have s squared minus 2s plus 4 y of s. This goes here. This goes here. This goes here. Minus 2s minus 4. That's 0. Wonderful. We have y of s is equal to 2s plus 4 over s squared minus 2s plus 4. I wonder if I complete the square, if I'll get an s. Oh wait, this should be minus. Meaning this would be minus 4. Oh, the first terms are positive. Are they? Yes, they are. My bad, my bad. My bad. So then this would be plus. That would be minus. Meaning, this will still be minus. Okay, 2s minus 4 over this would be plus. Okay. What would I do in this situation? Looking at the bottom, if I can get an s minus, if I could get an s minus 1, that would be ideal. Well, no, let me think. Can the bottom be factored out nicely? Let me see. S plus 2. No, it can't. I would just complete the square and see where it goes. So let's complete the square. This would be s squared plus, minus 2s plus 1 squared is equal to negative 4 plus 1 squared. S plus 1 squared plus 3. So then that would be, minus, you take the sign from that term. S minus 1 squared plus 3. This is 2s minus 4. That is really crooked. S minus 1 squared plus 3. Okay. So now if I'm at this situation, this is like the last video, I would need an s minus 1 on the top, right? So I would need to do this. And then I would do this. Right? Then I need another page. I would group these together since we have that s minus 1 now. Let's put that 2 out. Minus 2 over, we could this is like this one here. So we need b on the top, we need 3 on the top. If we multiply yes, multiply top and bottom by the square root of 3. Yes. So we're going to do this. I'll explain why in a minute. This is another fake thing that I didn't show in the last video. We're here. Guess what? That's that. Isn't that amazing? Isn't that amazing? That's something, isn't it? Anyways, this would become 2 e to the it's negative, so this would be, yeah, this is just t cosine of b, which is square root of 3. Same thing over here. Okay, minus 2 over root 3 e to the t sine, same thing, root 3 t. It's the same exact formula. All right. That's our little y of t. Okay. 13. We're almost there. We have a y to the 4th. See? I told you it can get bigger. No, no. I have a feeling this is going to be long. That's okay, though. That's okay. So we have s to the 4th. Oh, man. S cubed. Always a y0. And then we go to the primes. Okay. Next line. Minus 4 s cubed. Yeah, that's cubed. Plus, yeah, these signs are weird. 4 s squared y of 0 plus 4 s y prime of 0 plus 4 y double prime of 0. Wait a minute. S cubed, s squared. This should be triple prime, that's why. Okay. Phew! Good thing I caught that. Next term. S squared y s. Minus 6s y0 minus 6 y prime of 0 minus 4 s y of s plus y of 0 plus y of s is equal to 0. So let's go ahead and group together the y of s's. I try to keep them all on the same line. Now let's do all the let's do all the y sub zeros. It's y of 0 is 0. Goodbye. What about the double primes? What do we do with those? I forget what to do with those. Where did they get that from? Four S. Am I missing part of it? Wait. I'm probably missing part of the problem. I'll be right back. I was in fact missing the all the I.V.Ps. Okay. All right. Y prime is 1. So it's minus s squared plus 4s minus 6. That's 0. We just have that 1 left, so minus 1. So that's minus 7, right? Okay. Is this correct? I think so. Yes, it is. It's equal to 0. Y of s is equal to s squared minus 4s plus 7 over s to the 4th minus 4s cubed plus 6s squared minus 3. Wait. No, something's not right. It should be plus 1. Oh, wait. Minus 4s. My bad. Okay. I didn't see that s there. This is partial fraction decomp. This is a, let me find my answer. What is this, 13? Yeah. Okay, I thought, yeah, it's partial fraction decomp. Oh boy. This can, yeah. This isn't too, this is nice. This is one of those nice ones. So this can be rewritten s squared minus 4s plus 7 over s to the 4th minus 4s cubed squared or s plus 1 is equal to a over s minus 1 plus b over s minus 1 squared plus c over s minus 1 cubed plus d over s minus 1 to the 4th. Right? Because this bottom part can be rewritten as s, yeah, that bottom part can be rewritten as that. So that's how you would do this one. So now let's multiply everything by s plus 1 to the 4th. A times, oh man. Oh man. I didn't realize this one was so bad. Oh man. I suddenly don't want to do this anymore. That's the way these go, isn't it? Oh no. Oh no. Okay, let's rewrite this. Yeah, shortcut method won't work for this, right? How do you, that's what, s cubed. Oh, it's minus 3. It's 3 and then 3, so 3s squared plus 3s minus 1 plus b, and the squares are square. I'm trying to remember Pascal's triangle. Yeah, and then and then plus cs minus c plus d. Okay. 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 I don't need to do that step. Let's get right to the next step. So we, s squares. What about the cubes? Why did I forget the cubes? 0 equals a. Well, that was easy. Now let's do the squares. 1 is equal to negative 3a plus b. The s's. Negative 4 equals 3a minus 2b plus c. And then we have one more. Uh, 7 is equal to negative a plus b minus c plus d. A is 0. B is 1. C is negative 2. D is 4, right? Yep. So then we're left with 0, 1 over s minus 1 squared, minus 2 over s minus 1 cubed, plus 4 over s minus 1 to the 4th. We're almost there. Inverse Laplace time. Inverse Laplace time. I flew through that. Wow. Inverse Laplace time. We have a square. I think I'm looking at a bunch of Tn e to the ATs here. If I don't say so myself. A bunch of Tn e to the ATs. And based on my answer, I would agree. So let's see what's going on here. This one's simple enough. N factorial, yeah, 1 factorial. S minus 1 times 1 plus 1. Beautiful. Minus. 2 factorials 2. Yeah. Okay. Yeah, 2. No, it's not. It's 4. It's 2 factorial 2. Let me check that. Hold on. 2 factorial is 2. Okay, perfect. Then I'm assuming that... Then what the 4 be then? I should pull the 4 out? Oh, you just pull the... Yeah, you just pull the 4 out. Okay, that was... Okay, yeah. We're still good. This is 2 plus 1. Yeah, then that's 3 plus... Or 1 plus 3 even. For our n. We want n to be 1. Yeah, that works. That's 1 factorial. Okay, yeah. T to the n. So t, e to the a, t, that's easy enough, minus t squared, e to the t, e to the 2t, no, e to the t, plus 4t e to the t. Is that correct? No, my last term's not right. Let me see. Why can't I just do what I just did? Oh, it has to match the n, not the a. N can't be 1. N can't be 1. Oh, I didn't see that. Oh, man. Okay, it would have to be 3 then. Yeah. So the n will somehow have to be 3 factorial. 3 factorial is 6. Pull out a 6. That's what, 2/3? Yes. T cubed e to, yeah, okay, there we go. That's it. That's the answer. Y of t. Okay, I still have 2 more questions left, so I'm going to get moving on now. Piecewise. How fun. Let me see. 17. Oh, this one's not too long, by the looks of it. I can't see. Okay. So for piecewise, oh, I remember what to do. Give me 1 second. Yes, I know what to do. So y double prime, s squared, y of s, minus s, y of 0, minus y prime, plus 4, y of s is equal to, you add them up. These are our little f of t's. Integral 0 to pi. F of t is 1, e to the negative s of t dt. We have to use the definition, and this is exactly why we had to do, it's necessary to know how to do the first section. Because for this, you have to use the, well, actually, you know what? If I look at my table, well, no, because it's not, you can't use a you have to do this. You have to do it from 0 to pi. If it was from 0 to infinity, if it was f of t, if it was just equal to 1, then you can just look at your table here and be like, oh, 1 over s. But no, not this case. It's from 0 to pi, so it's different. It's it's going to be different. So let's take a look. Let me integrate that first. What do you think? That's what? 1 over s, negative 1 over s, e to the negative st, 0 to pi, e to the negative pi s, 0 is just plus 1 over s. So then this would be s squared plus 4 y of s. That's 1, so minus s, that's 0. I plugged in the initial conditions. Okay. Okay. This might not be too bad. I don't know. I can't tell. This would be plus s over s squared plus 4. Yep. Is that correct? Indeed it is. Oh. By the looks of it, they didn't want us to continue. Why not? Hold on. That's it. That's all I wanted, apparently. Okay, so for these last two, it just wants us to solve for y of s. And that's fine, right? So that's will be the answer for this one.